Hello everyone. Let's move on to another question here. This is 297. Serialize and deserialize binary tree. Alright, serialization is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer, or transmitted across a network connection link to be reconstructed later in the same or another computer environment. Design an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization or deserialization algorithm should work. You just need to ensure that the binary tree can be serialized into a string, and the string can be deserialized into the original tree structure. Clarification: the input or output format is the same as how LeetCode serialize a binary tree. You do not necessarily need to follow this format, so please be creative and come up with different approaches yourself. Okay, so example 1. Okay, so example 1, we have that tree. So let's just directly look at the example. I think this is quite straightforward. So example 1, we have left child of 2, right child of 3, the left child of 4, right child of 5. So in LeetCode, it will serialize it into 1, 2, 3, and then there is now, 4, 5. So I think it's pretty obvious how LeetCode do that. So basically we have 1, so we build 1, and then we build 2 and 3, which is the left and right child. And then the next would be the order type at the next level, which is child of 2, left child of 2, right child of 2, and then left child of 3, and then right child of 3. So I think it's quite straightforward in here. What we can do is, I believe this is what we call it is not a pre-order, but it is breadth first search. Okay. So what we are gonna do is, okay, let's see. So in BFS, in BFS we store the 1, then there is a child there, so remember to add the child 2 and 3, and then the child of 2 and 3, which is null, null, and 4, 5. And now null has no child. Now we move on to the 4 and 5, which is also null, null. Okay. So to deserialize it, in 1, 2, 3, null, null, 4, 5, we could do it by put in 1, then the left and right, 2, 3, then the left and right of null, null. The left and right of 2 would be null, null. Left of right and left and right of 3 would be 4 and 5. Okay, so let me just directly work on it. So first one, we work on the serialize the root. Here I'm gonna call it level Q. I think it's better to call it DQ. So DQ the root, then okay, let's do it this way, DQ, and then we have the current root level dot append the root. Okay, first of all, don't forget to check if it is a null or not. If root, then level dot append the root. Okay, so then we check my level. Um, my level, we look through all the node for node and level. So if it is a node, then what we're gonna do is we append the file. So I forgot to write down the serialize it, the serialize. Okay, so sequence. So I'm gonna call the solution sequence. Sequence, initialize it to entry, empty string. And then after I append it, I'm gonna sequence how about I just use a DQ? I think it's a bit of an optimization. So sequence.append to root. Okay. Okay, this is outside the if. Okay, let me just write down the comment. Outside if. Then actually I don't need to do it there. So actually, okay, forget about this. So for each node in the level, what if it is just a node? Okay, anyway, I think we don't need to check the root. We just directly append the root. So for each node, if it is a not, if not a node, I mean it is a none, then what we are gonna do is, wait, I would like to clarify one question. Is it gonna be a null? So the number of node, okay, I forgot to clarify that, so it complicates our edge case. Clarify one number of nodes. So in here we are guaranteed that there will be, okay, it's not guaranteed, so it can be 0 to 10 to the power of 4. So we need to handle the null. So if not node, then sequence dot append so what do you append here? The none. Okay. And then after we append it, we need to add a left and right chart. So that would be level dot append can I append two items in Python LeetCode? So let me check that. Yep, so we can append a list. So append. Okay, so I need to check else here. Else not dot left and then not dot right. Okay. In the end, everything will be null. Now I need to serialize the sequence into a string. What I'm gonna do is while sequence. Here I'm gonna call it str against that to empty string. Cat. Let me just call it not equals sequence dot pop left a node. Can I do that in the first while loop directly? Let me think. So I could just do it there. Yeah. Okay, so I just do it there. Yeah, I think so. So instead of using DQ, how about I just join it? Okay, I think it is slightly optimized if you do it this way. So, okay. Anyway, let's forget about this. Sequence. No. So str comma join. What do we join it with? So let's see. We can join the node.file for node.file. If not else, this is empty for node in sequence. How do we iterate a DQ? Let me see here. Python iterate DQ. So we can just directly use a for loop. Okay, so that is good for sequence. Okay, then in the end, we just return the str. Alright, so let me quickly walk through the serialize part so I don't miss anything. Sequence, and it means there's a sequence and level. Now level would be initialized to the root. So sequence and level. Level would have 1, while level we iterate the nodes. If not node, we return none. Otherwise, we append node left and right. Okay, and don't forget we could just append it directly. Node dot file. Okay, that could be better, but anyway. Level is 1. Sequence is 1. Now the level would be 2 and 3. Now we append 2 and 3. So the child of 2 and 3, that would be null and null, 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 4, 5. So this one would be just empty, empty, 4, 5. 4, 5 hash chart, which is just now, 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 now. So just comma, 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 comma. Okay, so I think the sequence works. Now let's try to work on this Deserialize. So for Deserialize, we just build the tree level by level. So we do it iteratively and recursively. I guess I'm going for the okay. I'm going for the recursive way because I think it is much more simple. I don't need to manage my own queue. So define the serialize of root. So if root, or let's say if not root, then we return none. Otherwise, we could return the tree node. So node equals tree node. Actually, it is called data there. Tree node. Wait. So data is a string. Sorry, we could not do it recursively. So instead, we need a similar step as the serialize, but just a bit different. So we could call a level equals dq. Now, so we are gonna do two chart at a time. Level and what do we call it here? You're gonna transform the data into a DQ. So DQ, let's see, data dot split. We split it by comma. Okay. Now, while there is data, right? First of all, we're gonna create the root node. If data level and tree node. Okay. So root, or let's just call it node. Okay. Initialize the root to none. If data, then we set the root equals 3 not value, we pop it from data. 3 not of value. And then level dot append the root. No, while level, so when there is level, then we create the left and right. So left, can I pop the button at the time? Let me check in Python. Python LeetCode, LeetCode pop to okay, we need to do it one by one. So left equals data dot pop left if left, then we create the left node. So let's see. Oh, I forgot to loop through for loop through the root. Let's just call it root in level. Level is a DQ, so we need to use a pop. Okay, so let me just rewrite the whole thing. Yeah, actually my serialize is also not quite right. But anyway, we will fix it when we write the code in LeetCode. So I'll note this is quite messy. So for all in length of level, not equals level dot pop left. If not node, then we just continue. Otherwise, we create the left and right. Left equals let's see, data pop left if left, then we create the data. Not any. Yeah. left equals 3 node dot left. Actually, I just call it the node dot left. Yep. And then I'll append it to the level. Level dot append node dot left. The end, I'm gonna return the root. I think that could work. Now let me quickly go through the code also to make sure I don't miss anything. And here I create a level, initialize to empty, and then data I just remake it into a DQ. Now currently the root is none. If there is data, then we pop left. Yeah, actually I need to just check it before I check the data. Otherwise it will be an empty string, I think. So we pop left and then create the root, append to level, and therefore its level. We are gonna create the left and right child till the end. You have all the three. So now let me quickly go through the example there. So we have 1, 2, 3 empty string, 4, 5 empty string, empty string, empty string, empty string. So data equals 1, 2, 3, empty, 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 4, 5, empty, empty, then empty, empty again. So now we have the root 2, 3, and then this would be just empty. 3 will be have 4 and 5. 4 and 5 have no chart. I think this could work. Let me quickly put it into LeetCode to make sure we got this right. Level is the queue of empty. Level dot append the root while level in level line of level not equals level dot top left. If not node, then we continue. Otherwise, we pop the data there. Oh, sorry, I'm looking at the wrong one. So if not node, then sequence, I forgot to write it. Sequence equal dq empty sequence dot append empty string else sequence dot append so the value here dot, okay, now we also append the left and right to explore further. left, no, top right. Return the string now. Let's make it comma separated. Top join. str file for file in sequence. Yep. Now the serialize part. Let's see what we need here. The node. Oh no, the level first. Level equals dq. Data. We change it into as dq as well. dq of data dot split. Split it by comma. No. Now we create the roadmap. So if data, we call it file data dot top left. Now as an edge case, the serialize if we are given, if we put in the empty root, then in this case it would just be an empty string. Yeah. So when we split it, we got an empty dq. No, we got a dq of one element of just an empty string. So now we check file, then root equals node of integer of file. Now level, we obtain the root. Done. Then we check while there is level. We look through the node. Node equals level dot append dot top left. If not node, then we just continue. Else, left would be the data, left, right, data dot top left, data dot top left. Now, if there is a left, then we create the left chart. Left equals node of integer of left. Level dot append the left. Same for the right. Then in the end, could return the root. to run it. Using a loop. Runtime error. Line. Which line is that? Line 92. We don't have line 92. Set line 20. Okay. The length of level. Level is a DK. So it should be the range. Yeah. And then error again. Oh, I thought I put it there. Sequence dot append not dot route. List object has no interior form. The node is a list. How is it possible? Let's try to clean the node. It's a 3 node. Why is that a list then? So anyway, this is a string. Let me try to run it. Node is level dot pop left. Let's try to print the node. Okay, so the root should not be like that. Okay, what now? We have 1. How come it's a list? Level dot append the root, sorry. Level dot append the left. Level dot top left. I'm a bit confused why there are 2 lines of output. So because I open two at a time. Yeah, I guess so. Because I appending a list, I'm thinking. Okay. This would be none. Yes. Time limit exceeded. There are a number of null there. Okay, so we need to further optimize this. How are we gonna do that? Okay, I think it's because I'm printing it. Yep. So now we got it right. Memory is efficient. Runtime is, I guess, it's pretty good. Let's compare it to some solution there. Okay, this is so simple. Yeah, this could work too. Yep, this also would work because I'm using DFS. I'm using BFS, so it's actually almost the same thing. I believe this is cheating. Let's look at the part where a lot of people have got pre-order. Yeah, this is using pre-order. I don't want to be so restricted to this kind of textbook solution, because in this case I could do that if I know what pre-order is. So I don't want to have that limitation, and I don't want to memorize the solution. So let's look at another example. Alright, so I believe there are a lot of ways to do this, but our solution definitely works. So yeah, thank you everyone. I think I'm gonna stop here. Hope to see you in the next video.